So we right here at the Tianma booth. So hi, so who are you?
Bob Nunhouse. I'm a senior FAE manager for Tianma up in Santa Clara, California.
So how soon are we getting these phones with the flexible OLEDs?
Well, actually, these are all prototype stage. This particular display has a strain sensor actually integrated into the panel, and then has feedback control to the actual content that you're seeing displayed here. This is how we expand the peacock feathers based on strain.
So that's definitely going to happen when you get the flexible phone, then the whole UI pops up when you flex it open?
Well, again, just ideas on how you may affect UI, as an example.
And right here, there's another flexible...
Another flexible display. This one can go as thin as a 3mm bend radius. And we can do up to 10,000 bends.
And the OLEDs don't get damaged or anything?
No.
So it's just gonna keep on closing, so you can totally fold it, put it in a bucket.
Down to a 3mm bend.
Nice.
See it from the top. That's right.
So why are so many companies making notch phones? You have some notch?
Yeah. Well, this is just an example showing where the earpiece would normally be. There are different variations which you'll see coming up that don't have the notch. This actually has an integrated pressure sensor. You can see here how the pressure indication at the bottom.
All right.
Completed again, replay, pressure.
So it's the flexible OLED with an integrated force.
Yeah, force sensor.
All right. You have some more smartphone displays in that corner. We can come back to here. You have a display with a hole.
So you asked about the notch, and as you can see in the graphic in the background, is that the problem with the notch is it actually intrudes into the actual visual image itself, and a lot of people don't like that. So there is a way to pattern the OLED display to provide an opening that you see right here, which would be used for a camera module.
Nice.
Yeah, I think aesthetically a little bit more pleasing.
And then another...
So, yeah, very similar, but in this particular case, now we have a cutout for fingerprint sensing. So we provide a fingerprint sensor in this area here as a combination of not only display but sensing.
And this is a no-notch.
It is.
Like a no-notch.
Yeah, this one is not OLED. It's actually based on low-temperature polysilicon. 300 nits, a very high contrast ratio at 1600 to 1. And very wide viewing angles as well.
And you have those round displays?
Yeah, they're more novel than anything.
But they're in the market, right?
Yes, these are actually in the market. It really just demonstrates that we can do round displays.
With all these apps and stuff going on, the kids are learning with this, right?
Yes.
And let's walk around over here. There's some more smartphones. You have no notch.
Yeah, this is no notch. This is full display. The one to your right will be same version, but with the notch again. Shows you the earpiece here.
This is AMOLED.
Yeah, AMOLED. And another AMOLED. This is real full high definition AMOLED. It's not a simulated resolution. It is actually full HD.
And it's working?
Yes, this touch sensor is integrated as well.
So all the icons are smaller?
Yeah, due to the resolution.
Nice.
1080 by 2160.
Nice.
It's just a couple examples of some OLED displays that are actually being used currently in smartphones. These are 5.5-inch displays.
Maybe it's out of power.
Yeah, it doesn't look like it's powering, does it?
Yeah.
Nope, not powering. This display is actually quite interesting. So some of the challenges with OLED is temperature sensitivity. This particular panel, this 4.2 inch AMOLED, came out of our Japanese prototype line, and it is an attempt to integrate into the automotive area, which requires much higher temperature. So this is a reformulation of OLED to withstand up to 85C. So right now, this particular display is capable of operating up to 1,000 hours at 85C, 10,000 hours at room temperature.
Nice. So that's some stuff going on with the automotive you're talking about. You have more right here.
More automotive.
Yeah. And this is
So it's just really kind of a technology idea of, side view mirrors, which is, that idea has been around for a while with cameras. And what this shows is what cockpit information can be. This is a single laminated, 3 displays with single lamination. So what we can do from a direct bond lamination. Yeah, the touch sensor is actually in here.
and some more stuff for the car.
Yeah, this demonstration really shows local area dimming. So they use mini LEDs, and this is the actual image, and this is what the backlight is doing itself. So you can see here the lighter area that was the picture, the flower before is lighting here. So this has 240 different individual areas that are independently controlled for luminosity. It analyzes the incoming frame data and then varies the backlight according to luminosity.
That just improves the contrast a lot, and the blacks are better.
Quite a bit better, yeah, quite a bit better. And also a little bit of power savings as well.
Nice. And it equals kind of some of the OLED a little bit?
Yeah, I mean, obviously the target is for alternative technologies to compete with OLED.
Yeah.
This is what we call our freeform display,
Yeah.
and it's really used to demonstrate that we can do really any shape. This particular display is a little bit more interesting though, because they added a hole in the center where they combine a mechanical sweeper for the odometer, for the speedometer.
Nice.
So, for that, it's what they find is, some people don't like pure digital displays because there's no three-dimensional information. So they can actually add a mechanical sweeper in this particular case.
Good afternoon, attendees and exhibitors. Thank you for attending the second day of
We have some more.
2018. The exhibit floor will be closing in 5 minutes. Thank you.
Another OLED, except with a not only touch sensor but haptic feedback, so you're getting a vibration every time you access a function.
Is it the whole device is vibrating?
Yes.
So everywhere the field can be felt.
Yes. Press, you can feel it.
Where was a display like this be used?
Well, I don't know. Again, this is prototype, so the application has not really been defined yet. It's really to create ideas, similar to what you're seeing here. This curved display. And right below that, you see the wheels themselves are full circular displays.
Nice. So you can do all kinds of shapes.
Beyond this is a privacy filter, but it's done electronically. So the left-right viewing angles are actually decreased depending upon the electrical drive to the privacy filter. And this is an ink-based filter, actually.
So how do you activate, deactivate? Is it always?
Yeah, actually, so what I can show you here is that with no electrical drive to the ink itself, the ink disperses. When it disperses, it creates these black fields that doesn't allow for wide viewing angles. When you apply a DC voltage to that, the ink then moves towards the polarized end, the positive end, which opens up the viewing angle.
And it's possible to turn it on and now it's just
It's
switching.
actually cycling right now. It's going.
So now it's narrow?
If you stand to the side, you'll see it transition.
Now it's narrow, there's no way to see it.
Well, you can see it from the side. You have to wait though. It's
And then it comes back to the wide. All right.
That's right.
Maybe we can go at the tactile.
Yeah, so this is tactile feedback, and there's two modes here. One is an electrostatic sensation, which you can feel as you move across the display. And actually, you can feel a difference in resistance as you come across that. It's an electrostatic sensation.
And this is going locally on the display.
It is
Where your finger is at.
Yes, it's graphics dependent. So you can only feel it during motion over specified areas. And then added to that, we have haptic feedback, which is vibrating the entire panel. So as you press, you're getting haptic feedback. So this is a PCAP sensor that multiplexes both the electrostatic feature plus the haptic feature at the same time.
So when I'm scratching, when I do like this, it's only under my finger that the haptics are happening, not the whole display.
That's correct.
Only this is the whole display.
Yes.
So how's it doing that?
Well, so this is a PCAP sensor, and in the PCAP sensor, the pattern itself is multiplexed with the electrostatic sensation that you get as you move. And then after you locate what you want to do, you're pressing down, and that PCAP sensing location is activating the piezo driver underneath the display to move this vibration plate.
Right.
And that's what's causing the haptic feedback.
Are these on the market yet?
This is not, again, prototype.
Lots of prototypes at the SID Display Week, right?
Yeah.
It's the coolest place to come to see the future of displays.
21.3, larger panel. This is using quantum dot to give very, very high color saturation, as you can see here. This is 120% of NTSC color standard, so very, very color saturated. This is a quantum dot film-based product. Again, still in prototype.
So is it the best LCD in the world?
That's what?
The best LCD that's possible to do?
Well, 120% of NTSC, it's extremely high color saturation. So the quantum dot technology is very interesting right now. The problem is that it uses cadmium. Cadmium's been a hindrance for the RoHS compliance, but now they have what we call reduced cadmium technology, which is RoHS compliant. It meets the maximum standard.
So the compliant of what?
RoHS is the reduction of hazardous substances.
So it was hazardous, but now you're getting down.
Yes, now it's down within acceptable levels. Mm-hmm.
So you hazardous in terms of it was a leakage, it could have been bad?
No, in disposal from a worldwide perspective, landfill type of perspective. That's right. Yeah. So 21.3 inch. It's high contrast. This one is 1100 nits. It's 2000 to 1 contrast ratio. Obvious uses is for medical imaging in that particular case. Very high resolution, 2560 by 2048. And this one's pretty high color for what it is. It's 70% of NTSC.
Nice.
Yeah.
You have some high brightness.
What you see on the walls is our outdoor viewable products. This is a combination of taking a standard transmissive display, adding a backlight recycling film to push more light through the display, as well as a proprietary AR coating on the outside. So most of these, straight out of the box, are 1600 nits, 800 to 1 contrast ratio. So outdoor viewable.
And what do you have here with the reflective display?
Yeah. Reflective displays are kind of making a resurgence. The improvements has been, what you see here is this is a 14% reflection ratio. But when you move over to the smaller displays here, they've actually been able to improve the reflection ratio. This is 25% of reflection ratio. So
25?
higher reflectivity. This one incorporates both a front light and a very, very high reflection ratio.
So there's a front light.
Front light's actually used for a crossover or nighttime.
Then if you go outdoors,
yeah, in pure reflection mode, that's ultimate power savings. But at night, you wouldn't have ambient lighting, so you would need to supplement that, and we do that by creating a front light in this particular case. Yeah.
so you have more high brightness.
More high bright. That's right. And we move into we actually make certain panels for high shock and vibe specifications. This one is what we call a 7G panel, so it can withstand 7 Gs of shock, and it's primarily for this type of application, industrial application.
There's some more wet.
Yeah, these are projected capacitive displays. This is our second generation displays. Intended for wet usage. So what we have here is, this is difficult for most displays, is when you have water on the surface. We have it tested with salt water, clear water, defib gel, ultrasound gel, and also cavicide, which is a medical disinfectant, which is quite difficult as well.
You can do air bonding.
We do both. We do both perimeter air bond and direct bond.
Get the highest quality.
Yes. For outdoor viewing would be for optical bond as an example. This is demonstrating custom cover glass. We actually have an extended cover glass here with a printed black matrix. This is actually an AG etch outer surface. Typically we leave with film solutions like an AG film or an AR film. In this particular case we did a glass solution, AG etch. So some customers need that for reliability and long-term usage. What you see up here is another PCAP control, but this one is extended field. You see here,
There's some sensor in front.
Yes, an extended capacitive field, but it also combines regular PCAP touch features as well. So this one is extended field.
All right. And on the wall you have some other.
These are also targeted for the medical applications. Full high definition, wide format. Both of these panels come in either embedded display port interfaces or LVDS interfaces. This is a 27-inch. It's a 4K by 2K display, so very high resolution. We laminated a piece of cover glass with a black matrix on it. A lot of people like this look. We can also offer this type of display with a PCAP touch sensor on it as well. This is a new 30-inch, primarily targeted toward radiology. What the radiologist wanted was 2 X-ray images side by side to do A/B comparison. The reason why that's important is the way it used to be is a radiologist would have 2 independent displays. The problem with that is as they age, they shift in color temperature. So doing A/B is very difficult. Thereby moving the same image on the same display makes them comparable.
Nice. And here's a special floating display. Something's going on right here.
This version is very
Yes. Yeah, you can see exactly where it converges. Yeah.
What is the floating that's happening right here?
Well, yeah, it's based on what we call our horizontal double density pixel structure, which is, in essence, is taking the vertical RGB stripe, rotating it on the side, splitting it at the subpixel level, and adding a lenticular lens on top of that to direct the left eye, right eye.
Is it like a holographic display?
It's an auto stereoscopic display.
Yes, it's angled.
Angled. All right. So there's lots of stuff happening with Tianma, and you are this is your locations?
It is, it is. So we're in Shanghai, Chengdu, Wuhan. These are manufacturing sites as well. We have an office in Japan. Of course, we're in the United States in Santa Clara and in Chino, and another office in Germany as well.